Good morning, guys. If you're watching this in the morning anyways, and if you're not watching this in the morning, good afternoon. Or possibly good evening, but hopefully not good night. Anyways, we've got Chapter 8, Lesson number 3, Volume of a Sphere. Super easy to do, you guys. We got a pretty good section here. Not difficult. So what we're going to do is we are just going to do 4/3. Pi r to the third power. So what you guys could do to make this a little bit easier for yourself, it's the same thing. You can do 4 times pi times the radius to the third power, and then divide that by 3 if you'd like to. Okay, many ways we can do this. In any case, let's go ahead and roll on down, and we will take care of number 1. Find the volume of a sphere round to the nearest tenths. Okay, so one common mistake here in this section, you guys, is we've been doing pi r squared quite often. So we have to remember that we are going to do 4/3 pi, and then we're going to do radius to the third power in this section. So that's probably the biggest mistake that I see kids make. All right, we're going to remember 4/3 pi r to the third, but for calculation purposes, I'm going to have you guys just do 4 times 3.14 times the radius to the third power. So we will do volume, and then we'll divide that by 3. So we'll say volume is going to be equal to, volume is going to be equal to 4 times 3.14. There we go, got to fix that. Times the radius, and the radius is 6 to the third power. And when we're all done with that, you guys, we will just divide by 3. Okay, let's see. Hopefully I don't run out of room here. I think I'm going to be able to pull this off. So we will do 4 times 3.14 times 6 to the third power. And 6 to the third power is 216. And then we'll multiply straight across, and then we will divide by 3. So let's go ahead and multiply straight across here, you guys. So we've got 4 times 3.14 times 216. And that's going to give me 2,712, 2,712.96, and then we're going to divide that by 3, and that will give us 904.32, 904.32. They are asking me to round this to the nearest tenth, so I'm going to say 904.3. We are dealing with volume, and we're dealing with millimeters, so I will say millimeters. Something like that, you guys. Millimeters to the third power. As I said before, it's super difficult to write with these digital pens, especially when you're trying to do some small text. All right, easy problem, you guys. Let's go ahead and move on down to number 2. So we've got a spherical stone in the courtyard of the National Museum of Costa Rica. It has a diameter of 8. So that's a diameter of 8 feet. Remember, we want radius, so we're going to take that diameter of 8 and we're going to turn that into a 4 because half of the diameter is the radius. And then find the volume. So and we're going to round this to the nearest tenth. So we'll go ahead and use the same formula here, you guys. We'll say the volume is equal to, hopefully remember this, we've got 4/3, we've got pi, and we've got the radius to the third power. Okay. Give yourself a pat on the back if you got that right there. All right, so let's go ahead and say that the volume is equal to 4 times 3.14 times the radius. Now the diameter is 8, so the radius is 4. And we're going to bring that to the third power. So, and then we're going to divide that by 3, right? 4/3. So we've got the volume is equal to 4 times 3.14 times 4 to the third power. That's 4 times 4 times 4, which gives me 64. And then we're going to divide that by 3. So let's just go ahead and multiply the numerator. We'll just go straight across right here with the numerator. And I think I'll put that up here at the top. So we will end up with 803.84, 803.84 in the numerator. How's that look, you guys? And then in the denominator, we've got a 3. So let's take care of that. So we end up with 267.946. And let's go ahead and round that to the nearest tenths. So let's go, the volume is going to be 267.9. And what do we got here? We've got feet, right? So 267.9 feet. Dealing with volume, we are going to cube that answer. And there we go. All right, number 3 coming up next. The volleyball has a diameter of 10 inches. That means the radius is 5. Remember that, you guys. A pump can inflate the ball at a rate of 325 cubic inches per minute. How long will it take to inflate the ball round to the nearest tenths? So kind of a tricky problem here, you guys. Before we address the question on how long will it take, let's just go ahead and find the volume. All right, so we're going to have to do that anyway. So we're just going to go ahead and say that the volume is going to be 4/3 pi r to the 3rd power. Okay, and we're just going to fill in the blanks here. So we'll say that the volume is going to be 4 times 3.14 times 5, because the diameter is 10, so the radius is 5 to the 3rd power. All right, and we will just, whoops, and then we're going to divide that by 3. So let me squeeze that underneath there. So then I'll just go ahead and say that the volume will be 4 times 3.14. Now, if you haven't figured this out, it's always 4 times 3.14, right, you guys? So you can kind of do that first in your calculator and then multiply that times 5 to the 3rd power, which is going to be 125. Okay, and after we do that, then we're just going to go ahead and divide by 3. So I'm going to multiply straight across there, 4 times 3.14 times 125. That's going to give me 1570. And then I'm going to divide that by 3. So the volume of this volleyball is going to be 523.33, and it's going to be minutes cubed. I'm going to leave that out for the time being. So here's the tricky part. We've got that. Now they're saying that we can inflate a volleyball that had 325 cubic inches in 1 minute. So if you look at ours down here, you can see, hey, wait a minute. Ours is a little bit more than 325, so it's going to take a little bit more than a minute, right? It's not, 523 is not double this, so it's not going to take twice the amount of time. So it gives us a pretty good, a ballpark guess as to what the answer might be. So to do this, I think it might be best, you guys, if we just go ahead. Let me take care of that right there. So if we go ahead and we've just set up a proportion here on the side. So I'm going to set up a proportion. And what I'm going to do is I'm going to say, hey, we could do 325 cubic inches in 1 minute. So I'm going to say 325 cubic inches in 1 minute. So then how long would it take if we had 523, so 523.33 in how many minutes? So I'm just going to call that X, okay? So if you notice here, up in the numerators, I've got the volume for both of those, and then in the denominator, I have the time for both of those. So I'm not too sure what chapter we did this in. I know for sure you guys did this in the 7th grade. I don't recall in the 8th grade what chapter it is, but it's really easy to do. We're just going to cross multiply. So we're going to do 325 times x, and 325 times x is just going to give me 325x. Is equal to, now I'm going to go ahead and cross multiply the 1 here times the 523, so that's just going to give me 523.33, and then hopefully you guys remember we're just going to divide by 325 here. 325 over 325, that just reduces to 1 or 1x, and over here we're going to divide this by 325. So when we do 523.33 divided by 325, it's going to give us 1.61. And what does that represent? Down here in the denominator, we were talking about minutes. So that represents minutes. So it's going to take about 1.6 minutes. All right. Not too bad. All right, you guys, we've got one more. This next one's pretty easy. And then we'll be done with this section. All right, last one here, you guys, number 4. So they want us to find the volume of a hemisphere. So that's really easy. If you look at this, you can see this is just what? Yeah, it's just half of a sphere. So we're going to go ahead and find the volume of the sphere, and that's going to be using this formula here. And then when we're all done, we're just going to take half of it. And how are we going to take half of it? Well, we can just multiply it by a half, or probably easier for you guys, just divide by 2. So I think that's what I'm going to do. I'm going to set this up, and I'll use the formula 1/2 to start off. But after that, we're going to kind of forget about the 1/2 for the time being, and then when we're done, we're just going to make sure that we divide this by 2. Okay? So let's go ahead and start filling in some blanks here. The formula is already down. So we're going to say volume is equal to 1/2. Now, I'm not going to write down the 1/2, you guys. So if you're doing this my way, you got to be really careful. I'm not going to write it down because at the end, I'm just going to divide by 2. So I'm going to say 4 times 3.14 times the radius, which is 5, to the 3rd power, divided by 3. And again, when I'm all done with this calculation, that's going to give me the volume of the sphere. This is half of that, so I will divide that by 2. All right, so let's continue on here. So we've got the volume is going to be 4 times 3.14 and times 5 times 5 times 5 is 125. And then we're going to divide that by 3. And remember, when we're all done, what are we going to do? You got it. We're going to go ahead and divide by 2 because we got half of this. So if I multiply the numerator, you guys, straight here, this is just going to give me 523. Let me double check that real quick. Yeah, that's what I said. It's going to give us 1570. Yeah, what did you guys hear? Something like 500? I don't know what you guys were thinking. 1570 divided by 3. And when I do 1570 divided by 3, I'm going to get 523. Maybe I was thinking ahead, you guys. 523, whoops, 0.33. Okay, that's the volume of the whole darn thing if this was a complete sphere. So what we need to do is take half of that, so you can multiply that by 1/2. Or you could just do 523.33, and then you can divide that by 2. And when we do that, we're going to end up with 261.67. So let's take that 0.67 and round that to 7. 261.7. We've got centimeters. Whoops, and we got a 3 because we're talking volume here. All right, boom, we are done with chapter 8-3, just like that. All right, you guys, good luck on your homework, and we'll see you soon.